My name is Matt Piper. I work here at the Institute of Healthy Aging. We work on yeast, worms and flies, and we try to discover any genetic or environmental manipulation that extends their healthy lifespan. And the point is, of course, that we don't want to learn how to extend the lifespan really of yeast, worms and flies. We want to understand how to extend the healthy lifespan of humans. And that really differentiates the research we do from any other type of biomedical research, like cancer research or arthritis or diabetes research. We think those things are actually symptoms of one common cause, and that's aging itself. So if we can treat aging, we can actually treat all the diseases of aging simultaneously. What you'll be able to see is that we have very old flies in one of these vials, and they sort of, like old people, they fall over and stumble around a bit, whereas the younger flies are much more active. They jump up and they climb up the sides of the vials. And I think this is a real demonstration that even though these organisms are sort of foreign to most people, is that you can actually really see that they get old and that they age, and so they're useful for our aging research. Approximately 70 years ago, it was discovered that if you feed a rat about 60% of what it would eat by choice when given free access to food, it lives for about 30–40% longer. And this turns out to be relevant for almost every model organism that it's been looked at. My particular interest is what it is about the food that's critical for that effect. And what we've found is that if you uncouple all of the parts of nutrition that go into a fly's diet, is that it's the amino acid, the protein component of the diet, which is critically important for determining the lifespan of the animal. So if you give an animal a very unbalanced diet, either having a lot of protein or a very small amount of protein, they don't live very long and don't do very well. But if you can get that balance just right, they live longer and they're healthier for longer. So we're now interested in what it is about the protein that's critical for that effect. So if we can understand that, then we can intervene in that molecular process and hopefully benefit healthy aging without affecting the diet too dramatically. There's a logical reason for why this may also be relevant for humans. There are some diets that are very imbalanced towards a lot of protein in the diet, for instance, and there's famous weight loss diets like the Atkins diet. Our evidence, at least in the flies and the mice, would suggest that if one continues with one of these protein imbalanced diets for a long time, that lifespan is very compromised. There's a very short lifespan in the end. Now, of course, that's not been shown in humans, but I wouldn't be rushing out and adopting one of those diets long term.